Hello everyone, welcome to tutorial number 8 in database CSEN 501. In this tutorial, we are going to introduce our last querying language, which is SQL. You already know about SQL from the lab. Today we are going to solve some exercises using the SQL. Let's start with the first one. Okay, in exercise number 8, consider the following relational database containing information about multivitamin tablets. It consists of 3 relations. So we have now 3 tables. Supplement table contain information about the supplement. Here we have the name of the supplement and the supplier. The substance, in this table we have the substance, the daily value, and the unit. And last but not least, the content. We have here the name, the substance, and the quantity. We can see that the name is a foreign key for supplement and substance is a foreign key for substance. The first question is, find all the nutrition supplements containing iron. So we want to get all the supplements that contains iron. Display the name of the supplement and the quantity. We want to get the name and the quantity. From where can we get these two information? Actually, we can get the name from here as well as the quantity. So at the end, we can get all our information from this table, because from this table we can find the name along with the substance, from which we can check whether it has iron or not, and we can get the quantity as well. How can we write such query in SQL? First, we write the things we want to see in our output in the select statement. So we are going to write select. We want the name and the quantity. Okay, so we can say c.name, c.quantity from content C. Here we renamed the content with C. Okay. We want the name and the quantity under a specific condition, which is when the supplement contains iron. So this condition can be written in the where statement, where C.substance equal iron. Okay, let's move to another example. List all the substance which are in centrum. So we want to get the substance that is found in centrum. Display the name, the quantity, and the unit. Let's check from where can we get this piece of information. Okay, the name of the substance is found here and here. The quantity is found in this table, and the unit is found in this table. So in order to get these 3 attributes, we need to join between these 2 tables. We can either do inner join in SQL or a product. Okay, how can we make a product in SQL? We can write what we want to see in the output in the select statement. So we are going to write select. We want the name, the quantity, and the unit. The name, the quantity from content, and the unit from substance. So we can say c.name, c.quantity, s.unit. From content C, substance S. This comma means that we made a product here in SQL. We can either do it like this. However, in this case, we should write the condition of the join in the where or we can do inner join in SQL. Since we choose to make it with a Cartesian product, so we are going to write the condition of the join in the where. What is the common attribute between these two relations? How can we join between these two relations? Actually using the substance. So we are going to say where C dot substance equals S dot substance, and we want those rows whose name are centrum only, so we can write and C dot name equal centrum. Okay. List the nutrition supplements that contain more than the recommended daily value. So we need to check that the quantity of the supplement is more than the recommended daily value. Where we can find the daily value in this table and the quantity in this table. So in order to compare between the quantity and the daily value, we should use these two relations. Okay, we want to display the name, the supplier, and the substance. The name and the substance are found in this table. However, the supplier is found in supplement. So at the end, we need to join the three tables together in order to do the comparison and to extract the output, which is the supplier, the name, and the substance. Okay, so we are going to write what are the attributes we want to see in the output in the select statement. S1 dot supplier, C dot name, C dot substance, from the three relations, from supplement S1, substance S, content C. However, since we joined the three tables together, we should write the condition of the join in the where. Okay, how can we join the supplement with content? The common thing between them is the name. So the name in content should be equal to the name of the supplement. And how can we join between these two tables and substance? When the substance here is equals to the substance here. So we should write this condition in the where S1 dot name equal C dot name and C dot substance equal S dot substance. Are we done yet? No, because we want the data of the supplements that contain more than the recommended daily value. So we want the quantity, the rows which have quantity more than the daily value. So we are going to state that and C dot quantity greater than S dot daily value. Okay. Create the table content specifying on update constraint for each foreign key defined. Now we want to create a table for create table content for this relation, and we want to make a constraint for each foreign key. Okay, how can we do so? First, we can create the table as we know from the lab. Create create table content. We have name, which can be varchar, for example, because it's a string. Substance, which is varchar. And the quantity, which can be int. Okay, now we have two primary keys, which is the name and the substance. We should write that these are primary key. We can do so by writing constraint primary key content primary key and specify the attributes that should be considered as a primary key. Okay, it's as if we combined these two attributes and we give it a name, which is primary key content. Now we want to make the foreign keys of this relation. We have two foreign keys, name and substance. We want to put on update constraint, either to on update, delete, cascade, or whatever. Okay, so we can simply write constraint, okay, and give it any name, foreign key, for example, supplement, foreign key, which is the name, references, supplement, on update cascade. Okay, and we can do the same thing for substance. Constraint foreign key substance, for example, foreign key substance references substance on update cascade. Okay, change your definition of table content, the one we have already done, by changing the data type of the column quantity to another data type. Now we want to change specific attribute in this table. We want to change the data type of one of its attribute. How can we do so? Simply we can just write alter table content. It's a query, means that we are going to change something in table content. What is the something we need to change? It is column quantity. So we are going to state alter column quantity and write the new data type here. Okay, for example, we are going to change it to float, so write float. Okay, this means that we are going to change the column quantity from integer to float. Okay, change your definition of table content by changing the primary key to become name only. When we defined table content, we stated that the name and the substance together are the primary key of this relation, and we give it a name, primary key content. Now we want to change the primary key to be name only. The best thing to do that is by dropping the primary key that we already gave it to the table and make another constraint to this table. So according to our solution in number F, we are going to write alter table content, and we are going to drop the primary key of this relation, which was called pk content. In F, when we defined the table, we make a constraint called primary key content that is consists of name and substance together. So we are going to drop this constraint Okay, now we dropped this constraint and we are going to make another one. Okay, so we are going to write again alter table content, add constraint pk content, which is a primary key name. Okay. Let's take another example. Now we have a relation schema of doctors, patients, and appointments. Okay. Doctors has a primary key of doctor ID, patients, patient ID, and appointments has two primary keys, which is the patient ID, doctor ID, and both are foreign keys. One references the patients and one references doctors. Display a list of pairs, including the full name of all patients paired with a doctor name, so we want the full name of the patient with the doctor name, whom the patient has had an appointment with, if any. Okay, so we want at the end the output to be the name of the patient and its corresponding doctor, if any, which means that if there is a patient that does not have an appointment, we should get it in our output as well. So in this case, if we have a patient that did not make any appointment with the doctor, we want to see his info as well. Okay, how can we do so? First, we need to get the full name of the patients from patients, the relation of patients, and the full name of the doctors from this relation. And to know which patient has made an appointment with a specific doctor, we should use this relation as well. So at the end, we are going to join the three relations together. However, how we are going to join these relations? We want to see the whole information of the patients, either they made appointment with a doctor or not. So we can simply do so by outer join in the side of the patient. So we can join doctors and appointment and all this together outer joined with the patient. Let's write in the select statement what we want to see in the output. We want the full name of the patients, P, patient, full name, D, doctor name, from doctors D inner join appointments. A. On, we should write the condition of the join here. On A dot doctor ID equal D dot doctor ID. Are we done yet? No, we should outer join with patient. Okay, so this is when we want the join to be on the side of the patient. So if we joined D with A and we want to outer join in the side of the patient, this should be a right outer join with the patient. So you are going to write right outer join patient P on P dot patient ID equals to A dot patient ID. Okay. Find the name of patients who have seen at least 2 different doctors. So if we have appointments and we have patient 1, Dr. X, patient 2, Dr. Y, patient 2, Dr. Z, patient 2, Dr. Z, for example. We want the patient that have done at least an appointment with 2 different doctors. So in this case, we are going to retrieve the one as output. Okay, how can we do so? First, the name of the patient, we can get it from this relation. To see which patient have done an appointment with a specific doctor, we are going to use this relation. So our output will be obtained from these 2 relations. Okay, what do we want to see in the output? We want the name of the patient, so we're going to write select P dot patient full name from okay, we want to check that this patient have done 2 different appointments with 2 different doctors. So we want to check that this patient, patient 1, has an appointment with X, for example, and another appointment where the doctor ID is not X. Okay, how can we do so? Simply, we can join the patient with appointment and with another appointment and check that the doctor ID here is not the doctor ID here. Okay, so we can write patient P appointment A1 appointment A2, where we should write the condition of the join P dot patient ID equal A1 dot patient ID and A1 dot patient ID equal A2 dot patient ID. However, we need to check that the doctor in A is not the same doctor. So we are going to state that and A1 dot doctor ID is not equal to A2 dot doctor ID. For each specialization, give the total number of doctors specializing in it and the total of their salaries. The name of specialty should be part of that output. Okay, so for each specialization which is found here, we want the total number of the doctors and we want to get the total of their salary. This can be done by the aggregate function, such as count, max, sum, and so on. Okay, how can we use this aggregate function? So we can use one of the aggregate function and get the total number of doctors. In order to count the number, we can use the aggregate function count to get the total number of the doctors and the total of their salaries, which means that we need to sum the salaries in this specialization. So in this case, we are going to use sum. And we should get the name of the specialization as well as the part of the output. Okay, so what we want to see in our output is select the specialization, because we want to see this as a part of the output. This is the first one. And the total number of doctors. So we are going to count the doctor ID. Okay? As, and give it a name. In order to see the column with a name, we can give it a name as number of doctors. Are we done yet? No, because we need to get the sum of the salaries. So, sum of salary as total salary, for example, from table doctor. We are going to get all this information from table doctors, from doctors. In order to get if we have table like this with the specialization, salary, and doctor ID. Doctor ID 1, specialization X, 500, 2, 300, specialization X, Y, 403, 4, 100X. We want to get the total of each specialization. So we want to get groups of specialization. We want to see the table at the end, something like this. Group X with the total of their salaries, which will be 500 plus 300 plus 100, 900, with the doctor IDs, which is 1, 2, 4, which are 3 doctors. So we are going to count the doctors, which are 3. And then specialization Y is the total of the salaries and the total number of doctors, which are 1. So at the end, we should group all the doctors with the same specialization. How can we do so in SQL? By writing group by, and here we are going to group by the specialization. Group by specialization. Okay, let's move to another example. Now we have a relational schema of professor, students, lectures, prerequisites, attended, TA's exam. We want the name and the ID numbers of students who did not finish their studies on time, exceeded 10 semesters. From where can we get the name and the ID of the students? From this table. This is the only table that has the name of the students. Okay, so we should use it in order to get the name of the students. How can we check whether this student finish the studies or not? Okay, we can do so by checking the by checking the number of semesters. Okay, to see whether they exceeded 10 semesters or not. Okay, from where can we get the number of the semesters? Simply, if we check table students, we will find that each row has ID, name, and semester. So simply we can check the semester. If it exceeded 10, then this student didn't finish their studies yet. So all the data we want to get can be extracted from table students. So we are going to select ID and R, name from students where semester greater than 10. Okay, let's move to another example. Names and ID number of students who are having more than 12 hours per week. How can we check whether the students have more than 12 hours per week or not? The name and the ID, we can get it from here. Okay? From attendant, we can get which student attended which lecture. And from lecture, we can get the total hours of the lecture. So in order to check whether this student attended more than 12 hours per week or not, we need to get or to join students with attendant and attended with lecture to know which student attended which lectures and the hours of these lectures. Okay, so the data we want to check is the name of the students and the ID. How can we get the total number of hours attended per week or attended in any time? For example, if we have in table lectures, CS1 6 hours, DB 6 hours, Math 4 hours, CS2 4 hours, and we have student X, for example, who is enrolled in CS1 and Math and CS2. Okay, we want to check whether this student is having more than 12 hours per week or not. How can we do so? We need to check the corresponding hours for each lecture, which in this case is 6, 4, 4. And we need to sum all these hours together. In this case, it will be 14. And check that this sum is greater than 12. So we need to collect or to get all the lectures that are took by this student and sum their hours. Okay, so we need to use an aggregate function sum in order to get the summation of the hours. So the aggregate function should always be stated in the select statement. Okay, so in select we are going to write the outputs that you want to see, which is s.name, s.id, and r, and any aggregate function we are going to use, which is in this case the sum of the hours. Sum l dot hours as sum, for example, from the three tables: student S, attended A, lectures L, where S dot ID and R equals to A dot ID and R, the condition of the join, and A dot lecture number equal L dot lecture number. Are we done yet? No, because we want to check that the summation of the hours took by this student is greater than 12. Okay, so what can we do in order to get the courses that are enrolled by this student? Okay, we can simply, after joining, we are going to have the table joined by this relation, which will be, for example, the name of the student Ahmed, for example, taking which ID 3, student Ahmed, taking mass 4, and student Ahmed, and here Ali, for example, 5. Okay, so in order to get the courses of a specific student, how can we do so? By grouping the courses of each student. Okay, how can we group the courses of each student? By using the primary key of this relation, which is in this case the ID and R. However, anything that appears in the select should appear in the group by. So in this case, we are going to group by s.name and s.id and R. Okay, now we will have a table with all the info about specific student Ahmed, all his courses, Ali, all of his courses, and so on. Do we want all these data, or we want the students who attended with specific number of hours? Actually, we want the students who have summation greater than specific number, which is 12. So at the end, we want the groups that have sum greater than 12. So we're going to write having sum greater than 12. Having, when we use having, actually when we want to put a specific condition for the whole group, we want to get the data of the whole group with a specific attribute, which is sum greater than 12. Name and ID of students whose names start with T. The name and ID of the students can be extracted from table students. So here we can write select names, ID and R from students. Okay, how can we check the first letter of a specific name? By writing where name like T. We want students which have first name T, and we don't care about the rest. Okay? And that was it for today. Thank you very much, and next time we are going to have a tutorial on SQL. We are going to solve some examples on the nested query. See you next time, and thank you.